Hello everyone, welcome to our video presentation. We are Capstone team number 71 and our project title is T.U.R.N.S, which is an abbreviation of Thapar University Routing and Navigation System. Our aim is to focus on building a navigation application based on augmented reality to assist people in navigation inside our university. This video is divided into 5 segments, namely problem statement, working and methodology, code explanation, final product, and conclusion. But before that, let's start with the introduction of our team members. This is Tanisha Goyal from Electronics and Computer Branch.
Good afternoon, my name is Antisha Goel. I'm currently pursuing Bachelor's of Engineering in the specialization of Electronics and Communications, and my team number is 71.
This is Monish Makkar from Electronics and Communication Branch.
Hi, my name is Chaitanya and I'm from Electronics and Communication Branch.
Hi, I'm Priyank from Electronics and Communication Engineering, and we are from team number 71.
Thapar is a place with lots of academic blocks, hostels, cafes, etc. And someone new in the campus might find it very overwhelming, and in some cases, they might even get lost. So, to overcome this problem, we have decided to make an application that helps the users guide through this huge campus easily. And to make this app, we used AR, that is augmented reality, to make the process seamless. Freshers would find very easy to locate their labs, tudes, and their lecture halls with it.
Now, onto the working and implementation. We spent a lot of time researching and found a variety of ways to implement our idea. Most of them required some extra external hardware which would decrease the utility of our application. So we decided to place AR anchors using true latitude and longitude. This method uses only the phone's sensors. First, we will save the latitude, longitude and altitude of the destination in our database. Then these GPS coordinates will be converted to Earth center Earth fixed coordinates and then to ENU coordinates to be displayed on the camera screen using augmented reality. ENU coordinates are based on the convention of east, north and up as the axis and the surface of Earth as their origin. ENU coordinates are also known as navigation coordinates as they are more intuitive and practical than the ECF coordinates, which is why we use them.
For our project, we are using Android Studio version 2020.3.1. For language, we are using Kotlin. Kotlin has been the official Google language for native Android development since 2017. It runs on Java compiler and Java compiler version we are using 1.8. So we are using certain libraries, APIs and dependencies which are camera API, refresh layout, GPS via Google Play services and animation via Lottie. So let's get starting with the working of our app. Our app is broadly divided into 3 activities: the splash screen activity, the main activity and then the AR activity. The splash screen activity loads up first when we open the app and it displays an animation for 3 seconds before moving to the second activity. Then we jump on to our main activity. Main activity basically has our app logo and a login button. After that, we go to the AR activity. The AR activity first asks for permissions to access the camera and the location of our phone. There are certain other things that are handled by this activity. Now let's look at all the handlers of our problems which we can face. First, when granted permission, our camera opens up, which is handled by the camera handler activity. There is also location handler, what to do when the location permission is provided and what to do if it is not provided. There is also a refresh handler which we have implemented using swipe refresh layout. Also there is very important activity which is rotation handler. What happens if we rotate our phone after granting all the permissions and after handling everything, we get to the maths of it. So this is a file which is ECF coordinates where we get the location from the permission we already granted and by that we get the latitude and longitude. Then we convert this latitude and longitude to ENU coordinates which is east, north, up, which is recognizable by the camera so that we can view it in our real world. We have certain places stored in our app already which it can identify by their latitude and longitude. For demonstration, we are using Rangoli Gardens, which is the residence of our beloved team member Chaitanya Kapoor, which has this latitude and longitude. So now let's get to the working of it. We open our app we get the splash screen, then we get to the main activity, and finally the AR activity, which hosts the camera. The camera opens up, and if it projects to a point which is the latitude and longitude already mentioned in our places file, which is Rangoli Gardens, it shows a circle size of AR, and if we click on it, it opens a card and shows its detail to us.
So as you can see that the splash screen is working perfectly fine, and when I click on this button, the camera should pop up. Yes, it did, and it's showing a point where the coordinates were taken from, and it's displaying the correct information. Thank you, Monish, for the kind words. And now I'm moving towards the point. It's still not deflecting, and when I move my direction away from the point, it's clearly not moving, because that's the exact spot where the coordinates were taken from, and that's the banner of my society.